Hello everyone, my name is Sai Nikhil of ECB section. My roll number is 20BQ1A04A9. I am here to give a seminar on network analysis on the topic nodal analysis. Okay guys, let's get into the seminar. The topic is nodal analysis. Nodal analysis. What is meant by nodal analysis? Nodal analysis is a method that provides a general procedure for analyzing circuits using node voltages as the circuit variables. Nodal analysis is also called the node voltage method. Some features of nodal analysis are as: nodal analysis is based on the application of Kirchhoff current law (KCL). Having n nodes, there will be n-1 simultaneous equations to solve. Solving n-1 equations, all the node voltages can be obtained. The number of non-reference nodes is equal to the number of nodal equations that can be obtained. Types of nodes. Let's see what are the types of nodes. Types of nodes in nodal analysis. Non-reference node, reference node. What is non-reference node? It is a node that has definite node voltages. Example, here node 1, node 2 are non-reference nodes. Reference nodes. It is a node which acts as a reference point to all other nodes. It is also called as ductum node. Type of reference nodes. Cause is ground. This type of reference node acts as a common node for more than one circuit. Another type is earth ground. When earth potential is called as a reference in any circuit, then the type of reference node is called earth ground. Steps of nodal analysis. Basic steps to solve. First, select a node as a reference node. Assign voltages V1, V2 and so on Vn to remaining nodes. The voltages are referenced with respect to the reference node. Apply KCL to each of the non-reference node. Use Ohm's law to express the branch currents in terms of node voltages. Nodes always assume that current flow from higher potential to the lower potential. Hence, current is expressed as I equal to V high minus V low by R. Next, after the application of Ohm's law, we get n-1 node equations in terms of node voltages and resistance. Solve n-1 node equations for the values of the node voltages and get the required node voltages as a result. Let's solve an example. See, find the current flow through 20 ohms resistor of the following circuit using nodal analysis. Step 1. Here there are three nodes. There are three principal nodes in the above circuit. They are labeled as 1, 2, 3 in the following figure. Step 2. The node voltages V1, V2 are labeled in the following. In the above figure, V1 is the voltage with respect to ground, and V2 is the voltage from node 2 with respect to ground. Step 3. In this case, we will get two nodal equations since there are two principal nodes 1 and 2 other than ground. When we write the nodal equations at the nodes, assume all the currents are leaving from the node from which the direction of current is not mentioned, and that node voltage as greater than other node voltage in the circuit. Write the equations like this. Nodal equations at node 1 is V1 minus 20 by 5 plus V1 by 10 plus V1 minus V2 by 10 equal to 0. By solving this equation, we get as V2 equal to 4V1 minus 40. Nodal equation at node 2. 4 minus V2 by 20 plus V2 minus V1 by 10 equal to 0. By solving this, we get as 3V2 minus 2V1 equal to 80. In the step 4, find the voltages V1, V2 by solving equations 1 and 2. Substitute equation 1 in equation 2. We get 3 into 4V1 minus 40 minus V1 equal to 8. By solving this, we get V as 20 volts. By substituting V1 as 20 volts in equation 1, we get V2 as 40 volts. In step 5, the voltage across the 20 ohm resistor is nothing but the node voltage V2 and its equivalent to 40 volts. Now we find the current flowing through 20 ohms resistor by using Ohm's law. I at 20 ohm resistor equal to V2 by R. V2 equal to 40 and R equal to 20. By substituting those values, we get current at 20 ohm resistor is 2 amperes. Therefore, the current flowing through 20 ohm resistors of the given circuit is 2 amperes. Note, from the above example, we can conclude that we have solved n nodal equations if the circuit has n principal nodes except the reference node. Therefore, we can choose nodal analysis when the number of principal nodes except reference node is less than the number of meshes of any electrical circuit. Thank you. So, this is my presentation on nodal analysis. Thank you. Thank you for giving me this wonderful opportunity. Thank you.